left off yesterday, as class was winding down, we were trying to identify what set of numbers each one of the numbers at the top belong to. That was very difficult for you all to bring together. Some people were coming up, some people weren't. Some people were volunteering others. It was kind of a mess. So bringing it together, let's take a look at 5. 5 was identified as being real, natural, whole, and integer. Is there anything you disagree with about 5, or would you add 5 to any one of these sets? Isaac? Okay, so we would add 5 to rational, because 5 can be written as a fraction, 5 over 1. Good. Now, square root of 9, is the square root of 9 rational? Fabian? Okay, he said, I don't think so. Does anyone else have a comment? Denise?
It is.
Okay, why do you think it's rational?
Well, because the square root of 9 and it is.
Yeah. So the square root of 9 is 3. So when you simplify the square root of 9, it is 3. So you can treat the square root of 9 as 3. So is the square root of 9 real? It's rational. Is it natural?
Yep.
Is it irrational? Did you guys hear how Charlize is answering? Can you guys answer as well? That would be awesome. How about whole?
Yes.
Thank you. Is it an integer?
Yes.
Great. Let's look at the negative square root of 3. DJ.
It could be a real number.
What do you think? Do you guys agree with DJ? Is the negative square root of 3 real? Please raise your hand. Brendan? Yes. Anyone disagree?
Oh, what am I?
Maggie, you disagree?
Yes.
Okay,
So
why?
No.
Go ahead.
Okay. Well, because there's the negative sign before the actual symbol, so once you figure out, you put the negative sign after, right? So it's still negative. And not actually.
So does that mean it's not real?
It's not real.
Okay. So I just heard Brendan J say it's going to be on the number line, so it's going to be a real number. So that's a really good way to look at it, is if it's on the number line, it's going to be real. So the negative square root of 3 is on the number line. Is the negative square root of 3 rational?
Yep. Yes, because it's still something that you can put in a fraction.
Now, be careful, because it has to be a fraction where the top and bottom number are integers. Now, that's not helpful unless you know what an integer is. Who can define integer for me? Brendan?
Any whole number that is positive or negative.
Good. So, is square root of 3 a whole number?
Yes.
And we need to get through that, though. Is the square root of 3 a whole number? Okay. Square root of 3 is like 1.7. So is this a whole number?
No.
No. So is the negative square root of 3 a rational number?
Yes.
Can it be written as a fraction where the numerator and the denominator are whole numbers?
No.
No. So the square root of 3 is not rational. If it is not rational, where do we write it? Irrational. And if it's irrational, if it's right here, sorry, that's supposed to be an arrow. If it is right here, if it's irrational, it's not gonna be rational, it's not gonna be natural, or whole, or integer. So remember that chart? It was rational on one side, irrational on the other side. All of these were real. And under the rationals, you had integers. Under the integers, you had whole. And under the whole, you had naturals. Okay? But if it's not rational, then it's irrational. But if it's irrational, it can't be any of these things. Okay. Denise, you had a question?
Yes.
Okay.
The definition of an integer, can you just say in whole number, power, and number?
Well, technically, yeah, you could. But saying positive or negative whole number is probably better because it really states that you're going in both directions on the number line, into the negatives and the positive. So there we go. Negative square root of 3 is both a real and an irrational number. How about the square root of negative 6? Where would we place that? DJ?
One of them could be real. Wait. Yeah,
So you're saying it's real?
yeah.
Okay, raise your hand if you agree with DJ. Is the square root of negative 6 real? Okay, so if we think of the square root of negative 6, we know the square root of 9 is 3 because 3 squared is 9. What can I square to get negative 6? Yes?
2.
2.
Wait. Oh, never mind. Oh, 4.
Isaac? Nothing. How about negative 9? What can I square to get negative 9? If I square negative 3, what do I get? Positive 9. So is there any number I can square and get negative 9? No. So this is actually an imaginary number. Okay? So that would go nowhere here. That is outside of the reals. How about 21/4? Is that real, everybody? Yes or no? Yes, thank you. Is it rational?
Yes.
Yeah, so notice that is a fraction where the top and bottom are integer values, positive or negative whole numbers. Is 21/4 natural?
No.
No, why not?
Because it's an improper fraction.
And you wouldn't count? It's not a counting
You
number.
wouldn't count 21/4.
You would not. Is it irrational? No, because if it's rational, it can't be irrational. Those are opposites. Is it a whole number, 21/4? No? Is it an integer?
Nope.
No. Great. How about 0? Is 0 real?
Nope. Oh, yes, yes, sorry.
I'm
I'm calling that a tie.
Nope.
So,
Is 0 rational?
300.
Thank you. Is 0 natural? No. The lowest natural number is 1. Is 0 irrational? No. Because if it's rational, it's not irrational. Is 0 whole?
Yep.
Yeah. The whole contains, think of this O, that means it contains the 0. Is 0 an integer?
Yes. It's not, no, yes. No.
Again, be careful with this on the number line definition. Integer, I really want you to say it's a positive or negative whole number. But a whole number includes the zeros. It is, yeah. So the integers are negative 3, negative 2, negative 1, 0, 1, 2, 3. These are our integer values. So yes, 0 is an integer. All right, are there questions on these? So remember, you gotta be able to put these where they belong. All right, so today we're gonna talk about how we describe intervals of real numbers. So if you have an interval of real numbers, that interval can be bounded or it can be unbounded. Bounded means it does not go on forever. And when we deal with applications in real life, those are going to be bounded intervals. So it will have a start and end point. And finite is kind of the opposite of infinite. That's what that means. So it's not going to go into the positive infinity, and it's not going to go down to the negative infinity. It's going to have boundaries. Having boundaries means it has endpoints. So what this relates to is when you all learn about inequalities. So you've done work with less than and greater than or equal to, and less than or equal to. And when you worked with those types of problems, you use the symbols, you know, like the alligator eating one direction, or the Pac-Man. Does that seem familiar? Like this. But now we're going to learn a different way to represent that, and that is called interval notation. So when we're doing interval notation, a clearer way to write that notation instead of using the greater than and less than, or the greater than or equal to and less than or equal to, are using parentheses and brackets to represent these particular concepts. So let me just show you how we would represent these intervals. So parentheses means the numbers are not included in the interval. Brackets mean the numbers are included in the interval. So when you're talking about real life, you would say things like, I'm going to have over 300 points this season. That's a lot. Let me think of a number. Let's say I'm going to have over 30 points this season. That means that it's greater than 30. That means that 30 is not included if I say over 30. Whereas if I say I'm going to have at least 30 points this season, that means I could have 30 or 31 or 32 or 33. That means 30 is included in the amount. And so to show not included, you would use parentheses. And to show included, you would use brackets. So on a number line, if we had two values, A and B, the way we show the graph is we use parentheses on the graph to show that those values aren't included. And previously, what we would have shown on the graph, instead of showing the parentheses, is we would have shown an open circle. And then we color in the middle to show that it's anything in between. So this would represent all the values between A and B, but not including A and B. So parentheses means you don't include the values A and B, but it's anything above A, but less than B. So you can write the graph with the parentheses or with the open circles to indicate it's everything in between but not including. So that's when you don't include the boundary points. And this is called a bounded interval because you're not going to infinity. Okay? You can also have where the points are included. So that graph looks like this. And it includes brackets instead of parentheses. And then before when you graph, you would use a closed circle. So that means the values A and B are included in the interval of solutions. So the answer could be A, or anything between A and B, or B. So all of those are included. So two acceptable graphs would be ones with the brackets, or ones with the closed dots. And you should have learned about the ones with the closed dots before, but now you're learning about the brackets. You can also have ones that are mixed. Ones that are mixed are where it doesn't include A, but it does include B. Okay? So you have an open circle on A, closed circle on B, and then vice versa. Okay? So let's draw that. So in this one, A would have the parentheses, B would have the bracket, and then this is vice versa here, and then it's all the values in between. And then
No, that was it.
it doesn't matter, you're doing weird stuff back there too.
Ow.
Your arms are very long, and I'm not blind.
I was. I do it, so I was so
Yeah,
He doesn't ever.
Right, so you can have any combination of these. Oh man, I messed up, sorry. This one would be open, and then closed, and this one would be closed, and then open. Yeah, okay. So when you solve inequalities, instead of writing your answer with a greater than or less than, you're going to be writing your answers with this type of notation. So your answers are going to be represented a little differently than what you're accustomed to. So if you were to graph the set of real numbers greater than 3 and less than or equal to 5. So greater than 3, less than or equal to 5. On the 3, would you have a bracket or a parenthesis? So we have to go 3, 4, 5. So we include, I always like to have one number before our interval and one after, just so we have a number line that has a little more on it. So on the 3, you said both of these. What did you call it on now? Parentheses on 3, because it's just greater than 3. It doesn't include the 3. And then what goes on the 5? Isabel? Bracket. And then what you need to do is shade in between. So that's the graph, and then the answer is 3, 5. So this is the answer, this is the graph.
So if it says something like a question like that, that's what we would do.
So if it asks for the graph, this is the graph, and this is just the answer. Okay? And this, the lower bound, always goes first, and then the high always goes second. So So again, if it's or equal to, you have a bracket. If it's just less than or greater than, you have the parentheses. Yes.
Okay, so if you have it on the left side, like you have the parentheses on the left side, so that's because it's like less than or equal to 5, right?
Yeah, so if it's or equal to,
Okay.
you get the
That's,
bracket.
so that's the keyword, okay.
Yeah.
Got it.
So the set of real numbers between 0 and 4 inclusive. What do you think inclusive means?
Including something?
Denise?
You do the.
Yeah, because it would include those numbers. So I do have to go above and beyond my interval by 1, just so I can show a little bit more of the number line, so it's not so condensed. So because it's inclusive, I'm going to use brackets. So inclusive, 0 and 4 are included, and then I'm going to shade or highlight in between. So make sure in between, in this case, is either a different color or it's darker than the regular number line, because you need to note that that is shaded, highlighted, whatever. And so you'd write 0, 4, 0 comes first because it's the lower, 4 comes second because it's the upper. Questions? So we can also have unbounded intervals. Unbounded intervals, either one side or both sides goes to infinity. And the infinity symbols look like sideways gates. So this represents infinity, but it also can indicate what is also known as positive infinity. So if there is no symbol in front of it, you indicate that as a positive infinity. Now, positive infinity is the right side of the number line because the numbers are going towards positive, very large numbers. So out here is positive infinity, and over there is negative infinity. It's important that you differentiate between both sides, especially when we get into graphing, because when we get into our two-dimensional graph, graphs will go to positive infinity, which is up and to the right, negative infinity, which is down to the left. So this becomes even more important when we're graphing a little more complicated things. So when we get to intervals that are unbounded, in other words, they go to infinity, and we have, for example, the set of real numbers greater than or equal to 3, that means it's not bounded. So one of the sides is going to go to infinity. So I'm going to graph 3, and I'm going to do one number below and above, just so I don't have a number line with just one number on it. Greater than or equal to 3 is to the right. And because it's or equal to 3, I'm going to use a bracket. Now the bracket needs to go to the right because I'm going greater than to them. And then I'm going to shade to the right because it's all numbers greater than or equal to 3. So if I have a highlighter, I'm going to highlight to the right. If I have a pencil, I'm just going to shade in to the right. So those represent all numbers greater than or equal to 3. Now, when I do the notation for that, I need to include the infinity sign. So the way that works is at the 3, I have a bracket because I include 3. Now the upper bound is actually unbounded. There's no upper number to this interval. So it goes to positive infinity. Positive infinity, you don't need a plus because it's implied. Now, can we ever reach infinity? No. So next to infinity, you always have a parentheses because you can never reach infinity. You can never equal infinity. So because infinity is not achievable, you can never equal it, next to the infinity, you always have a parenthesis. So the way I remember it is that infinity is round right here, so you put the round bracket next to the infinity. So that visually is very pleasing. You have the curve here and then the curved parentheses next to it. You would never put a hard bracket by an infinity because you can never equal infinity. It's a concept, it's not a number. Questions on that?
Nope.
So the set of numbers less than -2. So I'll put -2. What's one number to the right of -2?
-1.
Good. Then we have -3. What would I put on top of -2?
Put it in the negative.
Oh, yeah. -3. What goes on top of the -2? Parentheses. Is it facing to the left or to the right?
Right.
Oh, I heard a lot of
Right.
Left.
left because it's less than.
Left.
And then I'm going
Right
to
hand.
shade to the left because it's less than. Ooh, less than.
It's Margaret.
So now when I give the notation, am I going to start with a bracket or a parentheses? And then what?
Negative, oh, wait, wait.
Negative infinity is the lower bound, comma, -2, and then what?
Bracket? No, parentheses.
Yes. So it is much easier to indicate the notation after you do the graph. The notation, I really like creating it after I do the graph because you read the graph left to right. The graph starts going from negative infinity and it goes and stops at -2. It's a parentheses at both because infinity is always a parentheses, and then you have a parentheses here. Questions on that? Set of real numbers greater than than 2.5. So 2.5. Oh no, sorry, I'm gonna do better than that. You don't want to have a 2.5 really on your number line. I'm going to put a 3 and a 2, because why? What would you put halfway in between your 2 and 3? Bracket or parentheses? Which way does it face, to the right or the left? Right, good, because it's going to positive infinity. Because it's just greater than. Who wants to tell me what the notation would be?
Wait,
Logan?
would it be parentheses, 2.5 and then infinity?
Yep.
Parentheses?
Yeah, so the order is important. You have to put the lowest first, then the highest, and then you have to know which bracket or parenthesis you have. This one doesn't need a plus infinity because that is implied, although it wouldn't be wrong if you did. Questions on that? Okay. Now, hopefully you guys have had some experience with absolute value. Absolute value is simply how far a number is away from 0. So if you consider how far -3 is away from 0 on a number line, here we have -3, -2, -1, 0. -3 and 0 are 1, 2, 3 spaces away. So, like really, literally, it's the distance from 0. And when you guys get up in math, this symbol, these two vertical lines, end up meaning distance or value in so many other ways. But around a number, it just means distance from 0. So -3 is how far away from 0?
30.
Yes.
Could it Could you also do for the sake of taking away the negative?
Yes, I just wanted you to think of what it's always just take away the negative sign, and if it's positive, keep it positive. So it's so easy, but I really wanted you to think of what the actual definition is. Okay, so absolute value. Okay.
Here, I got it. Here, okay,
Okay. Whatever. So how about the absolute value of 15? How far is 15 away from 0? DJ? What's that?
Oh,
15. So the absolute value of a negative is a positive. The absolute value of a positive is a positive. How about if the absolute value of x equals 6? What is x? Maggie?
6 or negative 6.
Yeah. X can equal 6 or negative 6. How about if the absolute value of x minus 4 equals 12? What is x?
8 or 16.
16? You said 8?
Yeah.
Does 8 work?
No, plus
Negative
minus.
Nobody's like one.
Does negative 8 work?
Yeah.
What's negative 8 minus 4?
Or negative 8. Oh, negative 12.
Well,
So that works. 16 works because 16 minus 4 is 12. The absolute value of 12 is 12. Negative 8 minus 4 is negative 12. And the absolute value of negative 12 is 12. Good fun. So we're going to learn how to do those. But I just want to challenge you a little bit. All right. So there is your assignment. These are all odds. You don't have to do any all. And you do have 10 minutes to work, so I'd like you to get started. And for you guys, this is going to start on page 12 since you've already done your work on page 11.
We have to do all those?
Odds.
All.